graph for uniform motion. We have studied that when an object covers equal distances in equal intervals of time, it is called uniform motion. Come, then let us now study the uniform motion along a straight line with the help of the distance-time graph. The given table shows the distances covered by a car in fixed intervals of time. The first column of this table shows the time in the unit second, while the second column shows distance in the unit meter. Let us plot a graph of distance against time, taking time along the x-axis and distance along the y-axis. The scale on the x-axis of the graph is 1 centimeter is equal to 10 seconds, while the scale on the y-axis of the graph is 1 centimeter is equal to 15 meters. Now let us draw the distance-time graph. What can we understand from this graph? Since the distance-time graph is a straight line, it is clear that there is a direct proportionality between distance and time. The straight line in the distance-time graph shows that an object covers equal distances in equal intervals of time in case of uniform motion. Now, can you tell, in this distance-time graph, what does the slope of the straight line indicate? The slope of the straight line in this distance-time graph gives the velocity of a moving object. After studying the uniform motion of an object in a straight line by the distance-time graph, let us now study non-uniform motion in a straight line by the distance-time graph. Distance-time graph for non-uniform motion. As studied earlier, we know that if an object covers unequal distances in equal intervals of time, it is called non-uniform motion. Come, let us study the non-uniform motion of an object along a straight line with the help of the distance-time graph. The given table shows the distance covered by a bus in equal time intervals. In this table, the first column shows the time in the unit second, while the second column shows the distance in the unit meter. Let us now plot a graph taking time along the x-axis and distance along the y-axis. The scale on the x-axis of the graph is 1 centimeter is equal to 5 seconds, while the scale on the y-axis of the graph is 1 centimeter is equal to 5 meters. Now let us draw the distance-time graph. What can you understand on observing this graph? Since the distance-time graph is not a straight line, we can say that there is no direct proportionality between distance and time. Here, the distance does not change uniformly with time. That is, it shows non-uniform motion. This is indicated by a curved line on the distance-time graph. After studying the distance-time graph, let us answer one question. What difference do you see in distance-time graphs for uniform motion and non-uniform motion? For uniform motion, the distance-time graph is a straight line. That is, in uniform motion, the distance changes uniformly with time, while for non-uniform motion, the distance-time graph is not a straight line. That is, in non-uniform motion,